So in lesson 7, we're going to start talking about, in a little bit more detail, the equation of an exponential. It is given to you here, f of x equals ab to the x. We're going to get into ones that are a little bit more complicated than this, but this is one of the basics. In the last lesson, I said b to the x, but there is often a number in front of the b that stands for something as well. So, what does the a and the b stand for? So the a is the initial amount. So whatever you're starting with, that is what your a is going to be. And then your b is your growth factor. Or I'm going to say, or decay factor. Okay? So what they want us to do here is to write this in exponential form. Now, they're telling us that this is an exponential, but I would know that because I see how as my x is increasing by 1, this seems to be growing dramatically. And, you know, I could add 10, but that doesn't work from 15 to 45, so it can't be a linear. But it looks like I'm multiplying by 3, doesn't it? As my y's are increasing, it looks like each time I'm timesing it by 3. And that makes it an exponential because here it's multiplication. So in this particular case, my b is 3. I'm multiplying by 3. I'm growing by a growth factor of 3. And then my initial amount, well, that would be right here. It's my y-intercept when my x is 0. So my initial amount is 5. So how do I write the equation? F of x equals 5 times 3 to the power of x. Now, there is a way to check yourself. You can put this in your y equals, go to your table, and make sure that the table of values given matches what's on your calculator. There is also a way to pull the equation on the calculator, and I will show you that when we go over the homework on Monday. Exercise 2 says, an exponential function of the form y equals ab to the x passes through 2, 36, and 5, 125.5. So what they want you to do here is to create the equation, an exponential equation, and they have only given you 2 points. You don't have the initial amount. And as far as the b, or the growth factor, it is kind of hard to figure out when you only have 2 points. You know, if you were to graph these 2 points and connect them, you would probably make a straight line, right? And you could find the equation of a straight line, but it's an exponential. So we're lacking some information here, which makes it a little bit more difficult. So the steps that we have to follow to do this are slightly different. So this kind of problem is going to pop up a lot, all right? So these steps right here are important, all right? So if you see this on the homework or in review or whatever, you need to come back to this right here. By substituting these 2 points into the general form of the exponential, create a system of equations in the constants a and b. Well, all they're really saying is we're going to substitute in the x and the y. So this is an x value, this is a y, this is an x value, and this is a y. So I'm going to write it, I'm going to plug in the x and the y into that general formula. Now, before I do that, I am going to give you a little note here that I want you to write down that will save you a little frustration. You are going to put the larger x value on top. It might seem, you know, like, why is she saying that now? But you'll see in a second. So that is also another good piece of information. So when I look at my 2 points, this has the larger x value, so I'm going to use that first. I'm going to take my x and my y, and I'm going to plug it into my general formula. So my y is 121.5 equals AB, and my x is 5. And now I'm going to use the second point and do the same thing. So I have 36 equals AB to the second, all right? Now I still have 2 unknowns. I still don't know my A and my B. So step number 2 here is part of the directions as well. It says divide these 2 equations to eliminate constant A. So I'm going to highlight the word divide because that's very important. Recall that when dividing 2 like bases, you subtract their exponents. Okay, so I am going to just kind of draw a line here, and I'm going to show my little division sign. And I'm going to divide each thing there. So I'm on my calculator, I'm going to do 121.5 divided by 36, and that gives me 3.375. Now, when I divide my A's, they're going to cancel, right? A divided by A is 1. As long as I have something else on the right side, I don't need to write the 1. Now, when I divide my B's, remember, and that's what it's saying, recall that when dividing 2 like bases, you subtract their exponents. So I get B to the 3rd power. So the nice thing is I have now eliminated a variable. So once you do that, you can now solve for the other variable. So step number 3, and I should have starred that one also. So step number 3, actually I'm just going to star them all because they're all important. Solve the resulting equation from part 2 for the base B. So what I got in part 2, I'm just going to bring down here. So 3.375 equals B cubed. All right, well, how do I solve for B? I have 3 B's there. How do I get the B alone? Does anyone know? I am going to take the cubed root of B to the 3rd, because what is that going to give me? It's going to give me B, right? You divide the root into the exponent, and that would be B to the 1st. But whatever you do to one side, you must do to the other. So I have to take the cubed root of the left side. Now on your graphing calculators, I think probably by now you're experts, but just as a reminder, if you want to get the cubed root, you hit the math button and you go down to number 4 where it has the little 3 in front. It's not the same as 3 times the square root. And then when I type in 3.375, I actually get a decent looking number here. I get 1.5. All right. So we now have our B value. Our change factor, or how we're growing, is 1.5. All right, so we have a B. Now we need our A. Step number 4. Use your value from part 3 to determine the value of A. State the final equation. So I'm going to go back to my original y equals AB to the x, and I'm going to plug in 1 point. I'm going to use the first point because the numbers are smaller and there's no decimals. You can use either point. It doesn't matter. It will get you the same answer. So my y is 36. I don't know my A, but I do know that my B is 1.5 to the power of 2. So I'm just going to solve for A. So I have 36 equals 1.5 squared is 2.25. And I'm just going to switch the order and put the A second. I haven't changed the value of anything. That's just the way that we're used to seeing it, right? And then I'm going to divide each side by 2.25. And I get, on my calculator, I'm going to do 36 divided by 2.25, And that's going to give me 16. Look at that. I got some nice numbers there. That doesn't always happen. So I now know my A and my B. So the general formula for any point, not just those 2 points given, is y equals 16 times 1.5 to the power of x. And that is my final equation. Again, put it in your y equals, go to your table, make sure that this point and that point are both in the table. On the next page, exercise 3. For an exponential function of the form f of x equals ab to the x, notice how they keep flipping between f of x and y. They mean the same thing. It is known that f of 0 equals 8 and f of 3 equals 1,000. Find the values of a and b and write the equation. This is exactly the same as exercise 2. It's the same exact thing. They just wrote the points differently, but it's the same. So the points that I'm given are 0, 8, and 3, 1,000. So to get that formula, I'm going to plug them both in. I'm going to put my larger x on top. So that's this guy here. So I have 1,000 equals a b to the third. And I have 8 equals a b to the 0. And now I'm going to divide those. So 1,000 divided by 8 is 125. My a's are going to cancel, and I get b cubed because 3 minus 0 is 3. Now, to solve for b, I'm going to take the cubed root because that will give me b. But whatever I do to one side, I must do to the other. And then I get b equals, and the cubed root of 125 is 5. Now that I have my b, I can use one of the points to plug in and get my a. I'm going to use the first point because the numbers are smaller. I like when there's a 0. It just makes things a little easier. So I have 8 equals a times 5 to the power of 0. Well, this one's a little bit easier because what is anything to the power of 0? It's 1. It's the other reason why I like using 0. So really my a is 8. Now that I have that, I can write my general formula. So f of x equals 8 times 5 to the power of x. And what does this mean? It means that my starting amount is 8, which I sort of already knew, but I didn't really say that to you because I wanted to go through the steps. But you know, your starting amount is your y-intercept, which is when x is 0. So that already was that, but I wanted to go through the steps. And your growth or your changing factor is 5. Exercise 4 says an exponential function exists such that f of 4 equals 3 and f of 6 equals 48. Which of the following must be the value of its base, or its b? Explain or illustrate your thinking. So I think I'm going to go through the steps again, and we'll see if we can figure it out ahead of time. But I think it just makes the most sense to do exactly what we did in the last 2 problems. So I'm going to plug in both points. I have the points 4, 3, and 648. I'm going to put the larger x value on top. So 48 equals ab to the 6th, and 3 equals ab to the 4th, and I am going to divide that. So 48 divided by 3 is 16. My a's are going to cancel, and I get b squared. Now, how do I solve this? I don't have a cube like I did in the previous ones. Well, I'm going to take the square root this time. right? Because there's that invisible 2 there, right? A square root cancels a square. So I get b equals 4. Now I can stop here because I already found my answer. Now I could keep going to find a and find the general equation, plug in and solve for a. The only reason why I'm not going to do that is because it's a crazy decimal, but you would follow the same steps as you would in exercise 2 and 3, but you don't need to in this particular problem. Exercise 5 says, find the equation of the exponential function shown graph below. Be careful in terms of your exponent manipulation. State your final answer in the form y equals ab to the x. All right, it's a decay, it's decreasing, but everything that you do is the same. This is why I say put your larger x value on top. And in this particular case, the larger x value is this one. So I'm going to plug that in. So I have 1/2 equals ab squared. And then I have 128 equals ab to the negative 2. And now I'm going to divide these. So I'm going to divide 1/2 by 128. And that is going to give me, well, on the calculator I'm using, which is the one on my phone, it gives me 0.00390625. So if you got that, it's correct. But I am curious to know if that would be a neater fraction. So if I hit math and go and hit number 1 fraction, it does do that. It does do it for me, and it's 1/256, which is a little bit neater than that decimal with several decimal places. Again, my a's are going to cancel. Now, this is what they were talking about before when they said, be careful in terms of your exponent manipulation. At first glance, you might think that it's b to the 0, right? But it's 2 minus a negative 2, which is 4, all right? And so now, to solve this, I would have to take the 4th root, which is going to work pretty similar. Okay, so the 4th root of b to the 4th is just b. Now, when doing a fraction, you do each one separately, right? So, well, the 4th root of 1 is just 1. And then the 4th root of 256. Well, off the top of my head, I don't know my 4th roots. So I'm going to hit my math button, and I'm going to hit number 5, which lets me put in whatever kind of root I want. So I'm going to put a 4 in there. And then I'm going to arrow till I get underneath the root. And I'm going to put in 256. And that gives me 4. So my b is 1/4, which means it's decreasing, right? It's less than 1. It's decreasing. We already knew that, though, because just by looking at the graph. Now that I have my b, I'm going to plug in to my original. I'm going to use the same point that I've checked off. I don't want to deal with negatives if I don't have to. So I have 1/2 equals a times 1/4 to the 2nd power. Now our exponent rules tell us to square each of those. So I get 1 on top and 16 on the bottom and a. I just changed the order like I did before. Now, from here, the way that you do it, you can divide both sides by 1/16 or multiply both sides by the reciprocal, which is what I prefer, but either way is fine. And when I do that, I get 8. So my final equation is y equals 8 to the 1/4 x. Again, I would put that in your y equals, go to your table, and double check to make sure that the points given on the graph are in your table for this equation. Alrighty, exercise number 6. A bacterial colony is growing at an exponential rate. It is known that after 4 hours, its population is at 98 bacteria, and after 9 hours, it is at 189 bacteria. Determine an equation in y equals ab to the x form that models the population y as a function of the number of hours, round to the nearest hundredths. The second part I will address after I get the equation. So this is basically the same as all the other ones. It just happens to be in the word problem. They are giving us the 2 points. The first point, time is always x, right? And then the y is the bacteria. So it's 498. And the second point is 189. I'm going to follow the same steps. So I have 189 equals AB to the 9th, and then 98 equals AB to the 4th, and I'm going to divide those. And 189 divided by 98 is a funky decimal. So I got 1.92857. So I'm going to see what happens when I hit the math button. Number 1, fraction. 27 over 14 is a little bit neater. I thought it was going to be 1/2, but no, that would be too easy, wouldn't it? So 27 over 14 equals, my A's cancel, and then I get B to the 5th power. Oh, this is going to be funky. All right. I can see it already because I know that I have to take the 5th root of both sides, right? And the 5th root of 27 and the 5th root of 14 are not going to be pretty. So I think what I'm going to do, you can try and take the 5th root of 27, take the 5th root of 14, divide them and see what you get, or see if you can make it nice and neat and pretty, but I don't think that's going to happen. So what I'm going to do is I'm going to put this whole thing in the calculator just like that. So I'm going to hit the math button, number 5, 5th root, and I'm going to get under the root there. From there, I'm going to put in a fraction, alpha y equals number 1, or hit the frac, and I'm going to put 27 over 14, and I do get a crazy decimal. So I'm going to write a few of the spaces, 1.140373. And as we get further into this unit, you're gonna see crazy decimals. It's not unusual. So they want us to round to the nearest hundredths. Okay, so I'm going to say B equals 1.14. Now I'm going to find my A. So I'm going to use my first point only because it's smaller. So 98 equals A times 1.14 to the power of 4. And so I have 98 equals, and I'm going to do 1.14 to the power of 4 and see how crazy that is. So I get 1.6889A. I'm going to divide both sides by that. And that's going to cancel. So my A is equal to, I'm going to do 98 divided by 1.6889. And that gives me 58.03 when I round it to the nearest hundredth. All right. So now I'm going to put it into the original. So y equals 58.03 times 1.14 to the power of x. So that's my lovely equation. And now let me address the second part. Exponential growth can be modeled by y equals a times 1 plus r to the power of x, where r is the decimal form of the percent growth rate. At what percent rate is a population growing per hour? So this is another exponential. It's the same thing, but it's slightly more complicated. What's different is it has 1 plus the rate in in the spot where the B usually goes, right? We plugged in 1.14. So that little piece right there, we have, so the 1 plus the rate. Well, we found the same thing is 1.14, right? So if the 1 plus is already in that equation, that's sort of like a given. So if I get rid of that, it's telling me that my rate is 0.14. So they want to know what percent is that. Well, I would move the decimal twice, and it's 14% growth.